Hi, ready? Page 6, part 1, applying properties of integer exponents. Next on Aiken's How To Math. I can't use those properties of adding these exponents together. What I am going to do is this. I've got a negative exponent here. Remember, negative exponents need to be changed into positive exponents by flipping the fraction. That means I need to write this as a fraction. So I put a 1 under this. This right here is going to move into the bottom, and that exponent is going to change. So I'm going to rewrite this over here. 6 to the 7th power divided by 18, and now that I've moved it into the bottom, to the 4th power. Since I need to evaluate this, I'm actually going to write out that many 6's to show you exactly what's going on here. That's 6 to the 7th power. That's 6 times 6 times 6 times 6 times 6. So I've got 1, 2, 3, 4, 5, 6, 7 6's being multiplied together. Divided by how many 18's now? 4 of them. 1, 2, 3, 4. And what I'm going to do is I'm going to reduce this like it's a fraction, like this part right here. If I had this part right here as a fraction, I would say, what's the biggest number? That will go into 6 and 18. That'll be 6. 6 divided by 6 is 1. 18 divided by 6 is 3. Same thing right here. I'm going to reduce this. 6 divided by 6 is 1. 18 divided by 6 is 3. Same thing with this part. 6 divided by 6 is 1. 18 divided by 6 is 3. Same here. 6 divided by 6 is 1. 18 divided by 6 is 3. So what I'm going to do is I'm going to rewrite this with this many 6's up here. 1 times 1 times 1 times 1, all going to be equal to 1. I'm just going to write these 6's up here. I've got 1, 2, 3 6's left over. In the bottom, I have 1, 2, 3, 4. 4 3's that are being multiplied together. 1, 2, 3, 4. And I'm going to do this same process right over here. This is going to be 6 divided by 3, or what's the biggest number that will go into 6 and 3? 3. 6 divided by 3 is 2. 3 divided by 3 is 1. Same thing here. 6 divided by 3 is 2. 3 divided by 3 is 1. 6 divided by 3 is 2. 3 divided by 3 is 1. So now I'm going to multiply all these numbers I have up here in the top. 2 times 2 times 2 is 8. 1 times 1 times 1 is 1. Times 3 is 3. That's what this problem right here looks like once you evaluate it. You follow your rules of exponents, getting rid of that negative exponent. You write down how many 6's there are on the top, how many 18's, and you start reducing until you get as low as you possibly can go. Number 2 on page 6. I'm going to apply my properties of exponents. And one of my properties is if I have the same base and I'm multiplying, I can add these exponents together. So that's what I'm going to do. I'm going to keep my base. I'm going to add these exponents since I'm multiplying. 4 and negative 6 put together is going to give me negative 2. Times another property of exponents, anything raised to the 0 power is 1. Next property I'm going to use is the fact that I've got a negative exponent. Anything with a negative exponent needs to be moved across this division bar into the bottom, and that exponent sign needs to change. So I've got a 1 left over in the top, and 3 to the 2nd power now in the bottom. Again, this says evaluate. If it says evaluate, I should not have exponents left over. That means I need to leave the 1 in the top and take 3 to the 2nd power. 3 times 3 is 9. So my answer for number 2 should be 1/9. Number 3 on page 6. Number 3, not only do I have to apply the properties of exponents to this problem, but I also have to remember my order of operations. My order of operations tells me I need to do everything inside the parentheses before I do anything else, before I worry about this exponent on the outside. So let's look at the inside. Look at the top up here, the numerator. These have the exact same bases, so my property tells me that if I'm multiplying, I can add my exponents. So that's what I'm going to do. I'm going to keep that base of 3, and I'm going to add these exponents. A -4 and a +6 put together gives me +2. We'll look at the bottom. I have the exact same bases in the bottom right here. If I have the exact same base and I'm multiplying, that means I can add these exponents right here. And that's what I'm going to do. I'm going to keep my base, a 3 and a -1 put together, +2. And I've got a -2 as an exponent on the outside. I've got some choices here. I can do this many different ways. One way of doing this is to write it out, meaning take this 3 and write it out 2 times. 3 times 3. Same thing with the 6. 6 times 6. I need to reduce this and then apply this exponent on the outside out here. I'll look at this part. I want to reduce this like it was a fraction. Biggest number that will go into 3 and 6 is 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Same thing here. Biggest number that will go into 3 and 6 is 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Now that I've got those numbers as small as I possibly can get them, I'm going to go ahead and multiply these in the top. 1 times 1 is 1. 2 times 2 is 4. Now that I have one number, 1/4 inside here, I'm going to apply this negative exponent. This negative exponent means I need to flip this fraction around, and I'm going to do that. Four divided by 1 now. And once I flip it, this exponent changes to a positive exponent. 4 divided by 1 is 4 now to the second power. 4 to the second power is 4 times 4. You should get 16 as your answer to number 3.